Hey y'all, in this video we're going to look at these special parallelograms, and those are the ones that are equilateral, equiangular, or both equilateral and equiangular, and we know them by the names of rhombus, rectangle, and square. Now, since these are parallelograms, they have the same properties of the parallelograms, so I don't need to prove any of those or show any of those. I want to see if these have any additional special properties. And that's kind of the focus of the video. Now, I am not the best constructor of parallel lines, so luckily for me, there's a conjecture that makes drawing parallelograms and rhombuses much easier. And so we have conjecture C49, the double-edged straight edge conjecture, which says that if I have two parallel lines that are intersected by a second pair of parallel lines that are the same distance apart from the first pair, the parallelogram formed is a rhombus, which basically means that if I have a properly created straight edge, like a ruler, these two edges are parallel to each other, and so I can create a really quick parallelogram by just going along both sides of the straight edge, angling the straight edge, and then doing that again. And since I'm using the same ruler for each pair, the distance between the parallel lines is always the same, which means that this parallelogram that I drew has to be a rhombus. Okay, if I wanted to make a parallelogram that wasn't a rhombus, I'd have to use two different straight edges. Now, if I wanted to prove this, I'd have to use the fact that these parallel lines are the same distance apart, which means I'd have to remember my shortest distance conjecture, which means the shortest distance would be a perpendicular. So I'd have to drop a couple of perpendiculars, find my congruent triangles, and then go from there. We're not going to do that in this video. We're just going to use this to help us draw quick rhombuses. Now, any rhombus that I could draw with this skinny little ruler isn't going to be really good to use in the video to demonstrate the properties of a rhombus. And when I say the properties of a rhombus, I don't mean about the sides of the rhombus or the angles. We already kind of know most of what's special about those, right? Because a rhombus, remember, is a parallelogram, so the opposite sides and angles are all equal, right? We have, for a rhombus specifically, all the sides are equal as well. So I have used my sheet of cat stickers as my double-edged straight edge, so I'm going to name this rhombus cats. And I know that cats is a rhombus by conjecture C49. So I'm going to mark these sides as congruent. And so the sides are uninteresting for me, right? So let's look at the diagonals. All else fails, draw some diagonals. And remember, we can do this because any 2 points create unique lines. And so that's a construction and a postulate. And when I draw those diagonals in, I have my suspicions about what's going on with those two lines, and I can use, a corner of a piece of paper to kind of see that, oh, looks like those angles are right angles, which actually is quite easy to prove as long as I remember this is a rhombus. Now I can go back and look at parallel sides cut by transversals and alternate interior angles and blah, blah, blah. Or I can remember, oh yeah, this is a parallelogram, and I know that the diagonals of parallelograms bisect each other. So I know that those two lengths are equal, and these two lengths are equal. And oh, what did that create for me? A set of 4 congruent triangles, right? And I know that this angle is equal to that angle by vertical angles. And because these triangles are all congruent and those angles all correspond, I actually have all 4 of those angles being congruent. And if I have 4 congruent angles that go around in a circle like that, each of those angles has to be a 90-degree angle. So not only do the diagonals of a rhombus bisect each other, they bisect each other at right angles. Now, they're not congruent, okay? I made a rhombus that wasn't super squishy, so they kind of look close to being congruent, but I could squish my rhombus a bit, and I'll end up with one really long diagonal and one short diagonal, kind of like a kite. So if I look at the angles that are created, I also know, because of all these congruent triangles, that this angle equals that angle, right? And since they're opposite, angles are congruent in a parallelogram, I know those are going to be equal as well. So that means it looks like the diagonals also bisect the angles of the rhombus, and that's also going to be true up here as well. That's going to be bisected, and that's going to be bisected, all because I have 4 congruent triangles inside of that rhombus when I draw that pair of diagonals in. So now let's look at our trusty rectangle. I've named this one BLEP, and we know, remember, rectangles are equiangular parallelograms. And by quadrilateral sum, the sum of the angles is 360, and if there are 4 congruent ones, each of them is 90, and therefore a right angle. We knew that. We've actually known that for a very long time. We've also known about the congruent sides, opposite, parallel, and you probably also remember what's special about their diagonals. Now, because rectangles are parallelograms, we know that their diagonals bisect each other, right? That's what's special about the diagonals of a parallelogram. But then it's also really easy to prove that the diagonals of a rectangle are congruent. As soon as I draw them in, and I'm like, oh yeah, they're those overlapping triangles from the triangle unit. I can draw them out separately, terribly in my case. So there's a P, a B, and an L, and a B, an L, and the E, right? And I know it's a rectangle, so I know those are right angles. And I know that it's a rectangle, so opposite sides are equal. And very quickly, by side angle side, I have the 2 triangles congruent, and therefore I have, by corresponding parts, the 2 diagonals being congruent. So that's what's extra special about a rectangle's diagonals, is not only do they bisect each other, but they're congruent. So now let's talk about the square. Okay, and I know a lot about a square, right? I know a square is a parallelogram, I know it's a rectangle, and I know it's a rhombus. And so therefore, it has to have all of the properties of all 3 of those things. So I don't even need to draw in the diagonals or make any congruent triangles. I'm just going to use the things I know about a square. Because a square is a parallelogram, I know that the diagonals have to bisect each other. And because I know a square is a rhombus, I know the diagonals have to be perpendicular. And because I know a square is a rectangle, I know its diagonals have to be congruent. There's no need to go back to the whole, oh, it's a parallelogram, alternate interior angles, and blah, 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 and find congruent triangles. No, I'm going to use the definition. A square is a parallelogram that's also a rhombus and a rectangle, and therefore has the properties of all 3. So this takes us to the last conjectures of the polygon unit, C50, our 50th conjecture. Not really, I think we've had a couple of extra ones that were unnumbered, but our 50th numbered conjecture is the rhombus diagonals conjecture that says the diagonals of a rhombus are perpendicular and they bisect each other. Remember that bisect each other part comes from them being parallelograms. What's special about the rhombus is that they're perpendicular, but they are not congruent. Okay. C51 is the rhombus angle conjecture. This tells us that the diagonals of a rhombus bisect the angles of the rhombus. Then we have C52, the rectangle diagonal conjecture. It says the diagonals of a rectangle are congruent and bisect each other. Bisecting from parallelograms, congruent special for being rectangles, but they're not perpendicular. And finally, we have C53, the square diagonal conjecture. The diagonals of a square are congruent, perpendicular, and bisect each other. Bisect from parallelogram, perpendicular from rhombus, congruent from being a rectangle.